All right, let's dive in. We're about to go on a journey that happens billions of times a second, a journey most of us never even think about. We're going to follow one single, tiny packet of data to really understand how the internet actually works. Think about it. You click a link, and boom, in the blink of an eye, a whole web page is right there on your screen. But what really happens in that split second? It's not magic. Not at all. It's an incredibly fast, super complex process, and we're going to pull back the curtain and trace that entire journey. So here's the deal. Every single thing you do online, from loading a page to sending a message, starts with a request. And that request gets chopped up into these tiny digital messengers called data packets. For the next few minutes, we're going to be your guide and follow one of those packets on its epic journey, right from your screen, across the globe, and all the way back again. Okay, so where does this all begin? You might think it's in some giant far-off data center, right? Nope. It starts right where you are. Literally. Every single online journey kicks off on your local network. And the scale here is just wild to think about. Your computer and phone are part of what's called a LAN, a local area network. Just think of it like your digital neighborhood, all the devices in your home or office connected together. But to visit a website, our little data packet has to leave the neighborhood and get onto the WAN, the wide area network. That's the global highway system we call the internet. And this whole interaction is built on a really simple relationship. Your web browser, that's the client. It's asking for something. And the website you want to visit, it lives on some other powerful computer called a server. So our data packet's mission, its whole purpose in life, is to carry your request from you, the client, to that server. Okay, so our packet is ready to go. But wait, there's a problem. A big one, actually. You typed in a website name, with letters. But computers, they don't speak human languages. They speak in numbers. So the very first, absolutely critical step on this journey is translation. And this is where our first hero of the story comes in, the domain name system, or DNS. Its job is incredibly important. It takes that website name that you and I can read and translates it into a numerical IP address that all the network here can actually understand. Honestly, the best way to think about DNS is as the internet's giant universal address book. You look up a name, it gives you the number. That's it. Can you even imagine having to memorize a long string of numbers for every single website you visit? Because without DNS, that's exactly what we'd all be doing. It would be a nightmare. And this whole process happens in a flash. Your browser basically says, hey, I need to get to this website. Your computer shoots that request over to a DNS server. The server looks it up in its massive database, finds the right IP address, and sends it right back. And get this, all of this happens before our packet has even left your house. Okay, so here's a cool little detail. Your devices actually have two totally different kinds of addresses. You've got the MAC address. Think of that like a permanent, unique serial number for the hardware. It's used for local delivery inside your neighborhood, LAN. Then you have the IP address. That's for the big trip, for global delivery out on the internet highway, the WAN. And that IP address actually comes in a couple of flavors. There's IPv4, that's the classic one you've probably seen, the one with the dots. But, well, we were kind of running out of those, so we came up with IPv6, which has a way bigger address space. It looks a little different too. It uses letters and numbers and is separated by colons. All right, mission accomplished on the address front. Our packet now knows where it's going. But just like a road trip, you can't just floor it. There are rules of the road. And on the internet, the main rulebook is called TCP/IP. So the first thing you have to know is that your request to load a web page doesn't get sent as one giant chunk. Instead, it's broken up into all of these small, manageable pieces, our packets. Why? Well, it's way more efficient and a heck of a lot more reliable. If one little packet gets lost in transit, you just have to resend that one tiny piece, not the whole thing all over again. And this is where two key protocols work together as a team. You've got IP, the Internet Protocol. Think of that as the basic postal service. Its only job is to get each packet to the right address. But then you have TCP, the Transmission Control Protocol. This is like the certified mail clerk. TCP numbers every packet, makes sure they all arrive, puts them back in the correct order, and if one is missing, it asks for it to be sent again. So IP handles the addressing, and TCP ensures reliability. They're a dream team. Okay, success. After traveling across the internet, our packet arrives at the correct server. The IP address did its job. It got it to the right computer. But the journey's not quite over yet.
That server is a busy place, running tons of different programs, and our packet needs to find the exact right one.
Here's the best way to picture it. The IP address gets our packet to the right building, but once it's inside, it needs to find the right apartment. That's what a part number is. It's the specific apartment number for the application our packet needs to talk to. For example, anytime you visit a secure website, the ones that start with HTTPS and have the little lock icon, your data packets are headed straight for port 443 on that server. That's the standard, globally recognized apartment just for secure web traffic. And there are literally thousands of these ports, all organized into different groups. You have the well-known ports for standard stuff like websites and email. Then there are registered ports for specific software. And finally, dynamic ports, which are just used for temporary connections on the fly. So our packet delivered its message. Awesome. The server now does its thing and sends the website's data back to you in a whole new fleet of packets. But, this whole system isn't always perfect. What happens when things go wrong? What if a packet just gets lost? Well, that's where another little helper protocol called ICMP comes into play. Its job isn't to carry your website data. Its job is to carry messages about your data. So if a router somewhere along the path can't figure out where to send your packet, it uses ICMP to send a little error message back, like destination unreachable. It's basically the internet's built-in problem reporter. But let's bring it all the way back home for a second, because sometimes the problem isn't halfway across the world. It's right there in your room. What happens when your computer boots up, but for some reason it just can't get an IP address from your router? We've all been there, right? When that happens, your computer does something pretty smart. It actually gives itself a temporary address using a system called API-PA. Now here is the practical, real-world takeaway for you. If you're ever troubleshooting your network and you see an IP address that starts with 169.254, that's a huge clue. It's your computer telling you, hey, I can't talk to the router. The problem is right there on your local network. All right, let's wrap this all up with a quick pop quiz to see if you were paying attention. We talked about two main types of addresses, right? The local MAC address for hardware and the global IP address for the network. So which of these characters has no business being in a device's local hardware MAC address? And the answer is the period. Yep, here's the simple way to remember it. MAC addresses, the local hardware IDs, they use colons. IP addresses, the global network locations, they use periods. It's a tiny detail, but it instantly tells you exactly what kind of address you're looking at. And now, you know how to spot the difference.